This is the first video for Math 107 for homework over Chapter 5. So we start with just a small system of two equations and two unknowns, and the idea here is to solve it by the methods that you learned previously. One is a method of substitution, the other is addition, sometimes it's called subtraction or elimination. Okay, I'll just explain the methods and it's pretty easy to apply it there. If you want to use the method of substitution, well, let's say we have a different system. I don't want to do this one exactly. So this is 3, and you have 2x plus y equals 10. Then for substitution, you write one variable, isolate one variable. We could say y equals 3 minus x. Then you take this and you substitute it into here, and now you have an equation that's only an x. And you solve this for x. So I have x, well, that's a 10. X plus 3 equals 10, or x is 7. Now that you know x is 7, you take the 7 back into this equation and you find y. That's the method of substitution. Okay, now let me talk about the method of addition. In the method of addition, you add the two equations together. So if I have, whoops, lost the pen, x plus y equals, say, 3, and I have 2x minus y, this is convenient, equals 6. Fine. Okay, then I add the two equations together. I get 3x, but I get no y's. You have to set it up in such a way that when you add it together, one of the variables vanishes, and now you have 9. Now you can solve for x, then go back and solve for y. Those are the two methods. And now you have three equations and three unknowns, and the idea here is to write this as a matrix equation. The operative word here is equation. Okay. Equations have equal signs, so the idea is to break this out into three equations. You'll have the equation of coefficients here, matrix of coefficients rather, I'm sorry, that's nothing. 7, 4, 2, continuing down 7 minus 3. Remember, if you don't have one, you've got to fill it in with a 0. I do have enough here. So that's my matrix of coefficients. Oops. This multiplies another matrix, which is a column matrix, single column, and this is called a matrix, but a matrix with a single column or a single row is called a vector. So this is the vector of unknowns. You have to know these terms for the test. Vector of unknowns, okay? What's not known? X, Y, and Z, they go here. Here's your equal sign, and then your solution vector goes here. I'm sure you can, whoa, I keep grabbing that wrong thing there. And you can fill that in. This will be your solution vector. And that's the vector equation. There's a lot of matrices get thrown around, but I want you to be able to write this as an equation so you know what to do next. Again, we write this little 2x2 system as a matrix equation. So you put your your coefficients here, 4 and the minus 8. This is a 2x2 matrix and a 2. What do you put here if there's just a negative sign? It's a minus 1. The invisible one finally gets written. Okay, then you would have your unknowns, which is your x and y, go in here, equal sign, and then you have your solution vector over here. Minus 32 and your minus 6. This, of course, is your x and y. Right, there is your matrix equation. Now, for the augmented matrix, you combine these two equations. And I used to put a dotted line, but you don't have to. So you've got your 4, your minus 8, your 2, and your minus 1 right here. Then here's your negative 32 and your negative 6. Go here. Like I say, I used to do a little dotted line in here, but you don't have to do that. I sort of like doing it because all your matrix operations are going to be done on this augmented matrix. Augmented is something that's bigger, of course, and you make this matrix bigger by putting the solutions to it. Now for this problem, you use the augmented matrix that you put together from the previous one, and you begin Gauss-Jordan elimination. But you describe what you're going to do in each step. You have to learn about Gauss-Jordan from the videos, from the lecture videos, and from reading about it. But basically what you do is you look at a row and you figure out what you want to do with the row. And the first thing you want to do is turn this corner into a 1. So you take row 1, in this case, to turn that into a 1, you divide by 4. Right? And then once you get that done, that's like a little side calculation, you store the result in row 1. So you'll write that over here of what you're going to do, and then here's your matrix. So if I divide row 1 by 4, I'd get a 1 here, I'd have a -2, I'd have a -8, right? And then nothing happened to this row, I'll leave it in blue. Okay, let's go one more step. The next step, I want to take this and turn it into a 0. Okay, I could multiply the whole row by 0, that would do it, but that'd wipe everything out. So what you do to make a 0 is you combine it with the row above it. So you take row 2, and if I subtracted 2 times row 1, that's a side calculation, it doesn't bother row 1 at all, and then I store the results back in row 2. So I'm going to do that calculation right here. I would have row 2, which is 2 minus 1 minus 6. And now I'm going to have -2 times row 1, so I'll have a -2. This will be easier just to add them. And -2 times -2 gives me a 4. And -2 times -8 gives me a -16. Oops, no, positive 16. And then I add those. So I got a 0 here, which is what I wanted. 4 minus 1 gives me a 3. And I have 10. So that's a little side calculation. And when I go to write the matrix, I now store that result back here. So row 1 didn't change, I just borrowed its values, and I have a 0, 3, and a 10. And you continue in that manner. So put what you're doing out here, and then the result over here. When you go to do Gauss-Jordan, always use a matrix you just finished working on. You don't go back to the original matrix, you keep going with the matrix. And this will take more paper, and that's what that note says. Okay, this is a 4x4 matrix. Now in this 4x4, you see instead of writing X, Y, Z, and W or something, we've used X's throughout and put a subscript. And that's very, very common when you get to these larger matrices. So in your matrix equation, your unknowns are X1, X2, X3, and X4. Solution vector, you know what that is. And for your coefficient matrix, okay, the first is easy, 1, 1, 1, 2. But now look at the second row. This is the coefficient for X1, it's 1, 2. There's no X3, so you've got to write a 0, and then a 1, okay? And you know how to do the rest. Then you combine these two for your augmented matrix, and you do Gauss-Jordan on them. This is a big problem. You aren't graded on getting the right answer, you're graded on attempting to do the work in a reasonable manner. Some people do get the right answer. Some people make a sign error. How do you know you get the right answer? When you're done and you have your answers for X1, X2, and X3, and X4, you substitute them back into these equations and you see if they work. You put them in this equation and you see if it equals 6. This one, see if it equals -2, 12, and -16. What usually happens, it's very sad, it works okay for these three and fails here. Busy day here. So what happens is that the first three work fine, and then you put it in the last equation, or perhaps it's just this one that doesn't work, and it doesn't work. And that means it doesn't work. And you try it over and over again, and it still doesn't work. What happened? You probably made a sign error somewhere. It's actually very, very pitiful. But this is what a person goes through, and I just want you to appreciate the amount of work involved. People generally don't do these matrices by hand. They put them on the computer, and the computer does them. But you have to understand what's going on, because you don't take this class just to plug numbers into a computer. You take this class in preparation for a bachelor's degree, which means you're thinking that you're going to be one of the people, maybe not in this field, but in another field, you're going to be one of the people who are making the tools that others use. So you have to know what goes into making the tool, not just using it